A sprinkler controller mounted on an outside wall in a non-residential setting and connected via cord and plug requires ground fault circuit interrupter, or GFCI, protection. This requirement is rooted in ensuring electrical safety and minimizing the risk of electrical shock, particularly in damp or wet outdoor environments. GFCI protection works by monitoring the balance of current flowing into and out of a circuit. If there is an imbalance, indicating that current is leaking to ground, the GFCI trips the circuit, cutting off the power supply very quickly. This rapid response prevents dangerous electrical shocks. The National Electrical Code, or NEC, which is widely adopted and enforced, provides specific guidelines for GFCI protection in various applications. The NEC aims to safeguard people from electrical hazards, and these regulations are continuously updated to reflect advancements in technology and evolving safety concerns. Several sections of the NEC address GFCI protection requirements. These sections are crucial for understanding where and when GFCI protection is needed. For example, the NEC mandates GFCI protection for receptacles installed in readily accessible outdoor locations, as well as receptacles within certain distances of sinks, tubs, and showers. While a dedicated section may not explicitly state that all outdoor sprinkler controllers require GFCI protection, the overarching principles of electrical safety, particularly in wet locations, strongly suggest that it is necessary. Sprinkler controllers, by their very nature, are often exposed to moisture, either from rain, irrigation, or condensation. This exposure increases the risk of ground faults and electrical shock. By providing GFCI protection, any fault current leaking to ground will be quickly detected, and the power supply will be interrupted, preventing a potentially hazardous situation. In a non-residential setting, compliance with electrical codes is especially important. Commercial and industrial properties often have higher electrical demands and more complex wiring systems compared to residential properties. Therefore, ensuring that all electrical installations are up to code is essential for the safety of employees, customers, and the general public. Moreover, non-compliance with electrical codes can result in fines, penalties, and even legal liabilities. Electrical inspections are routinely conducted to verify that installations meet the required safety standards. During these inspections, the presence of GFCI protection for outdoor equipment, such as sprinkler controllers, will be closely scrutinized. Installing a GFCI outlet or circuit breaker is a relatively straightforward process. GFCI outlets are designed to replace standard electrical outlets and can be easily installed by a qualified electrician. GFCI circuit breakers, on the other hand, provide protection for an entire circuit. When choosing a GFCI device, it is important to select one that is rated for outdoor use. These devices are specifically designed to withstand the elements and provide reliable protection in wet environments. Regular testing of GFCI devices is also crucial to ensure that they are functioning properly. GFCI outlets and circuit breakers have a test button that should be pressed periodically to verify that the device trips and cuts off the power supply. If a GFCI device fails to trip during a test, it should be replaced immediately. Understanding the technical aspects of GFCI protection is essential for ensuring electrical safety. A GFCI device works by monitoring the current flowing through the hot and neutral wires of a circuit. In a properly functioning circuit, the current flowing through these wires should be equal. However, if a ground fault occurs, such as when a person comes into contact with a live wire, some of the current will leak to ground. This imbalance in current flow is detected by the GFCI device, which then trips the circuit, cutting off the power supply. The threshold for tripping a GFCI device is typically very low, around 5 mA or 0.5 amps. This sensitivity ensures that even small ground faults are detected and the power is quickly shut off. The response time of a GFCI device is also very fast, typically within a fraction of a second. This rapid response minimizes the duration of electrical shock and reduces the severity of injuries. GFCI protection is not only required for outdoor receptacles and equipment, but also for other locations where there is a high risk of electrical shock. For example, GFCI protection is required for receptacles in bathrooms, kitchens, and laundry rooms. These areas are often wet or damp, increasing the risk of ground faults. The NEC also specifies GFCI protection requirements for swimming pools, hot tubs, and spas. These locations pose a particularly high risk of electrical shock due to the presence of water and the potential for electrical equipment to come into contact with the water. In addition to GFCI protection, other safety measures can be taken to reduce the risk of electrical shock. These measures include using properly grounded equipment, avoiding the use of extension cords in wet locations, and ensuring that all electrical wiring is properly insulated. Regular inspections of electrical equipment and wiring can also help to identify and correct potential hazards. When working with electricity, it is always important to take precautions and follow safety guidelines. Never attempt to repair electrical equipment or wiring unless you are a qualified electrician. Always disconnect the power supply before working on any electrical equipment, and always use the proper tools and safety gear. Grounding is another important aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and cutting off the power supply. This helps to prevent electrical shock and reduce the risk of fire. All electrical equipment should be properly grounded in accordance with the NEC. The grounding system typically consists of a grounding electrode, such as a ground rod or metal water pipe, connected to the electrical panel. From the electrical panel, a grounding wire is run to each receptacle and piece of equipment. This grounding wire provides a low impedance path for fault current to flow back to the source. Surge protection is another important consideration for electrical safety. Surges are sudden increases in voltage that can damage electrical equipment. Surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors are designed to protect electrical equipment from damage caused by surges. Surge protectors work by diverting excess voltage away from the equipment and back to the grounding system. There are different types of surge protectors available, including whole-house surge protectors and point-of-view surge protectors. Whole-house surge protectors are installed at the electrical panel and provide protection for all of the electrical equipment in the building. Point-of-view surge protectors are plugged into individual outlets and provide protection for the equipment plugged into those outlets. Regular maintenance of electrical systems is essential for ensuring safety and reliability. Electrical panels should be inspected periodically to check for loose connections, corroded wires, and other potential problems. Circuit breakers and fuses should be tested to ensure that they are functioning properly. Wiring should be inspected for damage or deterioration. Any problems that are identified should be corrected immediately by a qualified electrician. In addition to regular maintenance, it is also important to be aware of the signs of electrical problems. These signs include flickering lights, sparking outlets, and burning smells. If you notice any of these signs, you should contact a qualified electrician immediately. Electrical safety is a shared responsibility. Everyone should be aware of the potential hazards of electricity and take precautions to avoid electrical shock. By following safety guidelines and maintaining electrical systems properly, we can all help to prevent electrical accidents. It is also important to be aware of the local electrical codes and regulations. These codes and regulations are designed to protect people from electrical hazards and ensure that electrical installations are safe and reliable. Contact the local building department or electrical inspector to learn more about the electrical codes and regulations in the area. Understanding the specifics of the National Electrical Code is crucial for compliance and safety. The NEC is a comprehensive document that covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and GFCI protection. The NEC is updated every 3 years to reflect advancements in technology and evolving safety concerns. It is important to stay up to date on the latest edition of the NEC to ensure that electrical installations comply with the current requirements. The NEC is organized into chapters, articles, and sections. Each chapter covers a specific area of electrical work. For example, Chapter 2 covers wiring and protection, Chapter 3 covers wiring methods and materials, and Chapter 4 covers equipment for general use. Within each chapter, there are articles that provide more detailed information on specific topics. For example, Article 210 covers branch circuits, Article 230 covers services, and Article 250 covers grounding and bonding. Within each article, there are sections that provide specific requirements. For example, Section 210.8 covers GFCI protection for dwelling units, Section 230.95 covers ground fault protection of equipment, and Section 250.50 covers grounding electrode systems. The NEC also includes tables and examples to help clarify the requirements. These tables and examples can be very useful for understanding how the NEC applies to specific situations. It is important to note that the NEC is not a design manual. It provides minimum requirements for electrical safety. It is the responsibility of the electrician or electrical engineer to design an electrical system that meets the needs of the application and complies with all applicable codes and regulations. In addition to the NEC, there may be other codes and regulations that apply to electrical installations. These codes and regulations may be adopted by state or local governments. It is important to be aware of all applicable codes and regulations to ensure that electrical installations comply with the requirements. The NEC is a complex document, but it is essential for ensuring electrical safety. By understanding the NEC and following its requirements, electricians and electrical engineers can help to prevent electrical accidents and protect people from electrical hazards. Therefore, in the context of the question, GFCI protection is indeed required for the sprinkler controller.